So that is 30,000 seconds, basically, that we want the lottery to be open. So basically, when this gets deployed, we're just going to check block.timestamp, which is kind of the current time, basically the time when the block was mined, and we're going to add 30,000 to that number, and we're going to say that that's how long the lottery is going to go. So we're just going to define a function is open. And it will take no arguments because it's just going to be checking something. It'll be public because that means basically anyone can call it. And it's going to, well, first we're going to have to say...
What language is this?
So this is Solidity. This is the language basically that Ethereum apps are coded in. It's kind of like C, kind of like JavaScript.
What's it called?
Solidity.
Solidity.
Solid ITY. Yeah.
John, can I think of a contract like a class?
Yeah, exactly. It's exactly, that's right. And so we're going to have a uint deployment time that's going to be set in the constructor. We'll do that in a little bit, but for the isOpen, we're just going to have uint block.timestamp greater than deployment time plus that number. Oh, actually, it is seconds, right? Block.timestamp is seconds.
Is there a way to make the screen a little bigger?
Yeah, definitely. Is that a little better?
Yeah.
Yeah, it was pretty small up there, actually. Yeah. Okay, so we actually don't need to divide by 20. It's just in seconds. So we'll just add this. Okay, so this is going to return true after 604,000 seconds have elapsed since the time of publishing the contract. So this is what we'll use when we want to close the contract out. So the next thing we should probably define is the constructor.
You have to poll that?
Okay, sweet.
Yeah, we're going to call that probably at a later date. Probably we'll let the owner close out the lottery
Sweet.
when it's finished, maybe, for example.
What's that?
No, so actually.
So the next thing we want to do is the constructor. This is basically something that's called once upon initialization. And the only thing we're going to want to do for now is just set deployment time to block.timestamp, which, as mentioned, is the time at which we've deployed the contract. So the next thing is basically making an entrance. So we kind of want to allow probably anyone to be able to enter. We want them to be able to pay as much Ether as they want towards the lottery. And we'll also need kind of a counter for how much has been submitted. So let's make this counter up here. Uint submitted funds, let's call it. And this, let's call enter lottery. And it'll be payable, and that's just a tag that indicates that you can send value along with the transaction. And we'll also make it public to allow anyone to enter the lottery. The argument, we won't have an argument. You can imagine there being multiple lotteries with IDs, but we won't do that. So the first thing we'll do is increment the submitted funds counter. I think it's message.value. Yeah, so there's a bunch of globals that are available in any contract, basically that are associated with the transactions at hand. So message.value is the number of, basically it's just the value that someone sent in Ether with that transaction. So we'll just increment this counter, and then we'll need some way to keep track of how much each user submitted. And so to do that, we'll just have a mapping. So the way that mappings are defined are from addresses to uints. And we'll call this user balances. So in our enter lottery, we're also going to want to add the message.value to our user balances mapping, right? So this is the mapping of balances by user. We're just going to add the amount that they submitted to their message.sender. There's a little bit of a bug here. If you submit 2 entries, this value will just be overwritten. So instead we can just do plus equals to get around that. Oops. Okay, so this is basically enough for entrance. Let's make a function to close out the lottery.
So
and
that's
then
how you declare an array in what's this language called again?
Solidity.
Solidity?
So yeah, so this is actually a mapping. So like in Python, this would be a dictionary. In
Okay.
JavaScript, it's an object.
Okay.
And it's just a key
Yeah.
value pair. And so it's a key value pair of addresses, which is basically users,
Yeah.
to uints, which
Right.
is just, yeah. And so we're just incrementing
Uh-huh.
the balances for this user. So we'll call close lottery. And this will be public only owner. And it will require is open to be false. So we'll require not is open. And that's basically it. We want to trigger the payoff now. So let's think about how to do that here. So let's call this payout. Public. It doesn't matter if it's only owner, anyone can call it. And so we're going to want to call that after closing out our lottery. And now we need to think about how we want to implement this. So
does that require like exit if you have a false there? Is that how does that work?
yeah, so require basically just throws an error if
Okay.
the condition is not met. So if you try to close the lottery before it's finished, this function won't execute,
Okay.
which is what we want.
Yeah.
So, okay, so the payout. So basically we want to award a random entrant, basically the sum of the balances. And so there's no good way to get a random number in Solidity, but basically for the purposes of demonstration, we'll just use block dot Coinbase. What's the random block dot block hash? Yeah. So this is the block hash of the latest block. It's kind of more or less a random number. So we'll just use that as a kind of winning probability. So this will need to be block dot block. And how do you get the current block number? Do you know?
Blocked up.
Like block hash takes a number. So how do you?
Maybe you just get the block. Well, this is block out number.
Oh, this one. Yeah. Okay, perfect. Okay, so this is our random number. It's a uint. Okay, so it turns out that we're actually going to need to store, in addition to this mapping of balances, we're also going to need a list because we're going to need to select from the array of entered users, and there's no way to do that with a mapping. So we'll do that with an address list. Entered users. And so in addition, when you enter, we're just going to append you to that list. Entered users dot push message dot sender. Okay, so this random number is a number between 0 and 2 to the 256. We're just going to mod that with the length of the list to get a random number between 0 and the length of the list. So, sorry, I'm in the way here. So we're going to take random number mod entered users dot length. And that is going to be our winning index, right? That's a uint. Okay, so great, we have the winner. So if we take entered users at the winning index, this is the address that we're going to pay out to. So the sum of funds is just submitted funds. Remember, we incremented that every time that someone entered. So that's the total amount that is going to be sent to this user. And so I think, I haven't sent. Okay, so dot transfer is the current way to do it. There's a lot of active development in Solidity, so sometimes I forget how to do things. But when you want to transfer funds to someone within a smart contract, the relevant function is dot transfer. And so we have this address here, and we want to call it dot transfer submitted funds. And that, I think, should be it. Can anyone see anything that I've forgotten or missed? It's fairly straightforward. It looks like about 5 functions. Any bugs? Anything that won't work?
How do you test this?
I know that was a little quick. So we're going to test it live. Andy, who's left, is going to build a front end. We'll probably submit a couple submissions from from like some test addresses to see if it works with some testnet ether, which doesn't cost anything. And actually, let's make it. Let's not make it a week. Let's make it like what's it like 5 minutes or something, maybe.
A couple minutes, maybe. Why is this so tiny?
Oh yeah, you have to go to the display. Yeah, screen preferences.
Whatever else do it.
That's fine too.
All right. So I am making a super basic, super ugly app on just HTML. Okay, this needs to get fixed. I can't do this. All right. Oh my god. Sorry, guys.
It's a cool background.
Thank you. I found it on Reddit. I just went to like the wallpaper subreddit and just went to the top posts all time. It's an easy way to find good backgrounds.
So no one's going to transact, so I don't need to send the address to anyone.
That's not what I want.
Send it to me.
I'll send it to you. Yeah.
How do I-
Any of you are on the Wi-Fi. Otherwise,
Very
I totally
confused.
change
I'm not a Mac person.
Oh, yeah. Go to scale.
What?
Yeah, that one. Yeah, and then go far left.
Far left?
Yeah, that
How long has Selenium been around for?
one. Since Ethereum started, so like 2 years ish.
Okay. And does Bitcoin have its own language or something?
Yeah, so Bitcoin has a scripting language that you can use to create like multi-sigs, some very basic functionality like that. It's not Turing complete, which means you can't build arbitrary applications on top of it. So that was kind of Ethereum's innovation. Solidity is Turing complete. It's much more dev friendly.
Cool.
Yeah.
Is there Wi-Fi here?
Yeah.
What is it?
I don't know.
Good, so probably knows.
High school conference?
Things that you need to instantiate a contract in like JavaScript are the address of the contract and then what's called the API, which stands for,
Application binary interface.
yes. I was going to say stands for I don't remember, but that sounds better.
Is it good?
Let me know you send that to me.
Yeah.
So I can't really do the close lottery until I know.
Here, my remix is not working. Can I just send you the code? And then can you, because remix will give you the byte.
Yeah,
for the
sure,
API.
sure.
Well, let me just confirm it on you.
Yeah, that's fun. We can do that.
Ugh, my MetaMask is not working.
All right. Well, so what I have so far, I'll explain to you guys what I have so far while I figure this out. Really, really basic, hideous Java HTML code. You do front end. Don't judge me.
Okay, I do mobile. I don't care.
Okay. Then, as far as JavaScript stuff, one of the easiest way to like interact with anything Ethereum contract is what's called Web3. It's a library made to interface with all this stuff. The first thing we have to do is basically instantiate the contract and to get the instance of it that's saved on the Ethereum blockchain. The two things you need for that are the API and the contract address. So I know the contract address, I don't know the API yet, so I can't really call anything.
Web3 is specifically for Ethereum?
Yeah. So
Okay.
what I'm doing,
I got it.
you got it?
Yeah.
I hacked your way in.
Yes.
What I'm doing right here in this highlighted code is basically checking to make sure that you have MetaMask installed. MetaMask is a plugin that will basically let you interact with Ethereum-based applications and stuff on your browser. If it's not installed, it will give you like a pop-up, but I do have it. Then I'm hosting this app on Firebase. I think I already have it. Here we go. Hydro Meetup app. It's really really nice. Put a lot of work into this front end. So this, I'm loading your account right here. So when the page first loads, you can call it web3.eth.getAccounts, and so this will basically look at your MetaMask and see the account address, which you can kind of see here. It starts at 6.8. It starts at 6.8, and so that gives you any like address that you're working with, and you need this to call certain functions. It's basically say like I'm calling this function from this account. So I coded up enter lottery. I think it's right. It's hard to say without trying it yet. It's super basic. Basically, I made a little bit of a front end where you can enter in how much you want to enter in Ethereum. So you can say we want to enter 1. When you press submit, it would call enter lottery, which loads your accounts. In a perfect world, I would store these accounts in like not loaded every time, but I didn't feel like it for this. It's a little bit more involved. Then here we're actually calling the contract function. So we're saying my contract, get the methods from that contract, which are loaded based on the ABI. So right now it doesn't know that it has methods. This is we want to call enter lottery. There's two different types of methods in Ethereum. There are ones that actually change what's happening, like in the state. If you're like saving data to the Ethereum blockchain, and for those you want to do what's called a send, because you're actually like sending some data, or you have to send Ethereum as a transaction cost. But alternatively, for things that don't save anything, that are just reading data, those are called calls, and so those you don't have to pay for. Those are free. They're very fast. There's no block confirmation or anything. You just get the data immediately. To enter the lottery is a send because you're pushing to the contract. This is my address. Here's how much Ethereum I'm giving you. Save this in the contract. So that requires you to send Ethereum. And then since then you have to wait for the transaction to be confirmed, we have to do this and wait. This.
How much Ethereum are you giving?
For the transaction fee?
Mm-hmm.
It depends. MetaMask will calculate that for you. When you go to send stuff,
MetaMask?
that's this plugin. When you send transactions, it'll basically calculate how much.
What other types of apps does MetaMask interact with?
You ever use like EtherDelta or Fork Delta?
Yeah.
So you can use MetaMask for that.
If you go on stateofthedapps.com,
Yeah.
they have like 10,000
So if you-
apps.
Okay, so just pretty much any DApp
Yeah, MetaMask is essentially
run on
just-
Ethereum will interact.
For the most
with
part.
Yes.
It's
Yeah.
the easiest way to interact with Ethereum in a browser.
So if I like,
From an application
Okay.
standpoint.
That makes sense.
I don't know, never been to this site, so I don't know how good it is. But I would imagine, I don't know what it is, but I would imagine I could use MetaMask for this. All right, do I have the ABI now? Or?
Yeah, I slacked you. The address is right above it.
Oh, all right, it's a new address. Okay, so this has to go here. And then this goes there. Okay. So I should be able to make that contract now. So what is, I guess I have to set up a function call for closing the.
So, sorry, a question about
That's
Ethereum.
right.
So you have to pay to transact.
Yeah.
But you also have to and you pay in Ethereum,
Mm-hmm.
and then you're also sending Ethereum to the lottery.
Yes.
Yes.
But what is the amount of the Ethereum that's going to the lottery?
So you get to, so there's a couple things. So you get to pick how much you send in any transaction. It's often 0, and it can be, in the lottery's example, it can be anything you want, from 0 to whatever.
Oh, it can be zero. You can send nothing.
You can send nothing, so that doesn't mean you aren't going to pay for something. It just means you're not sending any value with your transaction. But you do have to reward the miners who are doing the work of verifying a
And
transaction.
is that just to execute whatever the contract is the reason you would send nothing?
That's exactly right. So you don't send any value, but you do need to send money to the miners in reward for.
And you can send anything you want to the miners.
No. So the way that it works is when Solidity compiles things down to bytecode, each byte string is associated with a cost. So when you want to pop something or push something or whatever, it's associated with a cost in gas. So like say it's 20 gas. So when you execute a function on a smart contract, it adds up all the gas you've used. Let's say it's 1,000 gas in total. That's the number of units of gas that you have to pay,
Yeah.
and you can choose how much ether you want to pay per gas.
Mhm.
And so that's something you set along with your transaction. So if you know something's going to cost 1,000 gas, and you say I'm willing to pay 0.01 ether per gas.
Gas is just GAS.
It's GU, so it's just GAS, but it's just a small quantity of ether. It's usually denoted in GUI, which is or GUI, which is the smallest amount of
Ethereum. It's
smallest
like a penny.
denomination.
Okay.
Yeah. And there's a market for gas. So basically, if you've heard of the mempool in Bitcoin, the mempool is the number of transactions that are unconfirmed that are waiting to be included in a block. If the mempool is ever full, meaning there are more transactions pending than can be confirmed in the next block, you'll often see people reward miners more in order to get preferential treatment. Basically, they'll tell miners, I will pay more per unit of gas than anyone else, and the miners see that transaction, they say, that's something that's going to reward me disproportionately, I'm going to include that in the block.
Say you had set that this lottery is going to last 5 minutes,
Right.
and there was a backup of, so say I was trying to submit it and I did it with 4 minutes and 40 seconds left,
Right.
and I didn't choose to pay any preference.
Saying that I'm sending 0 Ethereum.
So the actual code that was,
No, that's right.
the actual code that was submitted to be processed as a smart contract, that was just the 5 functions that you typed up.
That's right.
All of this is just the front end.
Exactly, yeah. So, yeah, all that Andy's doing is basically making a front end and creating kind of wrapper functions for MetaMask, which is what actually interacts with the blockchain to send transactions.
Come on.
I made some entries, which we'll be able to see.
Why is this
Worse
not
and worse
working?
and worse.
Alright, take a look at this and tell me what I'm doing. So, let me log what's going on here. This is why you don't try to speed code Ethereum
Yeah,
contracts.
it's maybe not the best idea.
That's alright. It's more fun this way. Alright. Yeah, same one. Then when I pass it in here. Is something wrong? Is it not value when you
Yeah,
pass
it
it?
might not be value.
I could have sworn this.
So can you tell me a little bit more about hydrogen? What you guys do here?
Yeah, so we are, Hydrogen as a whole is an API company. Not API company, but like essentially we build out APIs. We started from a robo-advisor called Hedgeable and spun out into Hydrogen because Hedgeable allowed consumers to, like, it was a consumer-facing investment app, and we found out that a lot of like large enterprises wanted our software to build into their own financial applications. So Hydrogen spun out of that, and Hydrogen has,
What was that API?
so Hydrogen's API is like core is like to build fintech apps, wellness, and stuff like that. But
What
now
was the hedgeable API, the original one?
it's the same APIs that we're using for Hydrogen.
Okay.
But it was like your enterprise oriented APIs that ran Hedgeable, right?
Yeah, essentially, they're more robust than just the use that they provide for Hedgeable itself.
Yeah.
And so now Hydrogen provides those
And I wanna
APIs
send it all. That's fine.
all the way from developers who are trying to build their own fintech apps
It was working before.
to large enterprises that have applications and want to add sort of functionality that comes from the Hydrogen APIs. And particularly within that, we just launched
I guess you can enter
we're
it.
launching a machine learning component of it, and then Hydro is the blockchain component of it, because it makes sense if you're building a fintech app, an enhancement on that fintech app would be blockchain functionality. And so we're creating like a modular set of fintech applications that will try to anybody an app via our API. First level is security, and that's what we built out so far. This is kind of where I
But
came
it is
on.
close, so it is
So we're working on the blockchain
Although no,
stuff.
it'll-
The three of us just
China-
work on
I
the
didn't
blockchain
require
part of it.
the close.
And
So it's fine.
we've got 2 security products so far. One of them is to secure databases, APIs, and large systems. And so that one's live on Ethereum, and it would be used, let's say like I'm a large bank,
Nice.
and I issue up an API so that stuff like Venmo or Mint can hook into to access my users' checking accounts. Obviously, if somebody were to access that API who weren't authenticated properly, then they would have access to all my consumers' checking accounts, which is really dangerous. And so we use a blockchain-based authentication system where you have to conduct a very specific transaction on the blockchain in order to be granted access to a system. And that's great. The thing is, it doesn't work for a lot of like user-facing products because you can't require someone to store something on chain every every single time they want to log into their Facebook account or something like that, because the same property it takes 20 seconds to clear, you have to pay every time.
Yeah.
And so we just put together, I don't know if you were here for it, I showed you the demo of our.
Okay, so using blockchain, you don't have to use Ethereum to use blockchain.
No, we launched the ERC20 token so that we can build these modular blockchain components on the Ethereum blockchain.
Yeah, it's done kind of like a smart contract ecosystem. So right now, Ethereum is kind of the only thing you can use, the only realistic platform you can use to make smart contracts right now.
Oh.
Yeah, if
So
other,
in this case, blockchain and Ethereum are kind of the same thing.
Oh.
It's the only real option that you have. But generally speaking, there are going to be other platforms that come out in the future that mature a little bit more, and then you would have a whole host of
yeah, we chose Ethereum because right now there's a lot of advantages to using it. Ethereum's there's thousands of people developing on it around the world, so we can leverage that.
All right, so I figured out what was happening. Actually, the code wasn't wrong. I was just being an idiot, which is classic. But so one of the issues you have to deal with when doing Ethereum-based development and stuff like that is if I want to send one Ethereum, I actually have to send 1 times 10 to the 18 in value of what I want to send. It has to be just because of the way that they deal with decimal places. They don't so it's all unsigned integers, and it's all just integers, so they don't have decimal places. So they just pick like an arbitrary amount of numbers, and those are the decimals. And so I was sending 1, and so I was sending 1 times 10 to the negative 18th Ethereum. And so you can see I did send it right here. I sent 1 way, which is the smallest form of Ethereum. I was just confused because it was showing 0 because MetaMask doesn't show that much. So I just typed in 18 zeros because I was too lazy to make it programmatically do that. So here you can see I'm going to submit another entry. That'll take a second. I'll go from here. The testnet's been very slow lately.
So,
That's my address.
so for the sake of this demo, you actually have to have an Ethereum wallet and have some money in it.
Yeah, so there's anyone that's interested in doing this should be using Rinkeby or Robston, which are both test nets. And so there are faucets for these test nets that give you Ether on them, and they're like not valuable, but you can use them. The like smart contract functionality is the exact same as on the real net, the main net, but you can basically test all your
So you
functionality on these test nets.
You can see here, I entered the lottery from my account with 1 Ether called Enter Lottery. Now,
Let's close it out.
let's close it. So I added the function for close lottery, so I'm just going to do this the easy way. And close lottery, and I believe this will close the lottery. But we shall see. Close lottery is not a function. Is that what you called it?
No.
That would do it.
No, it is. Close lottery. Yeah, it's fine.
Let's see. Oh, I should probably do that. Okay. Close lottery is not a function. How dare you?
I can close it
So
here.
going back to the 2FA thing, so a fee is gonna be needed to be paid when you execute the smart contract to authenticate whoever, say, is accessing the API.
Yeah.
Figure it out.
Is the user or, the company that's submitting the request paying that fee?
Yeah, so
Or are you guys covering that fee, and is it paid in Ethereum or is it paid in Hydra?
Okay, so for our 2FA, this is a little bit complicated, but essentially this particular app doesn't have much of a fee. It gets paid when a user gets onboarded. So we're incorporating it into the payment structure with whoever's using it. And that fee gets paid in Ethereum, but whoever's paying it has to have Hydro in order to execute the transaction. And yeah, so the end user in the mobile device, they'll never touch it. They don't have to know anything about blockchain. It's an app that's going to get released in the App Store, iOS. There's no like MetaMask for iOS right now or anything like that. The interaction right now is being done through our API.
So you're saying that there's a delay there, right?
We can go through the app again since a few people showed up.
Yeah, since
There's no, it's all right. There's no delay based on what we're doing for this.
Refresh that.
That was kind of one of our main goals is, and one of the kind of the downsides of cryptocurrency right now, building on Ethereum or any of these, is for some things there is going to be delay, and so trying to work around that and make systems that are still useful while dealing with that can be definitely a challenge. But at least for this, we were able to find a way to work around that.
Okay.
But so here you can see I just closed the lottery. So I don't know how the payout works.
I didn't log it, which
So
was
it's not
How
logged.
did you close the lottery?
Anyone can close the lottery as long as the amount of time had passed. That was
Oh,
required.
anyone can do it?
yeah.
But originally I saw that you had the syntax in the prototype that said have user, be user, or owner.
That's right. So I required it to be only owner, which meant that only the person who deployed the contract could call it.
Which is you, okay.
Which is me. But I messed up and didn't paste my code or copy my code, so I just didn't do that.
Oh,
In the
okay.
version we deployed, I didn't have that.
So
So
that
that was
you
just
took it out, yeah.
I did take it out. Yeah.
I thought it was I thought it was a compilation error.
So how do we know who got it?
It should say internal transactions, but they don't log that on Rinkby.
Well, I guess I can just I can see.
Disaster.
if I
It was
have-
3 Ether, so someone won 3 Ether here.
Alright, I don't have 3 either in mine.
Let me check who it is.
Don't think it's me.
How many entrants were there?
I think it was just us three.
No, actually, I think I forgot to enter.
Oh yeah, your transaction failed on the run.
Yeah. Because I did it before.
I don't think anyone got the
ether.
ether. I think you made a pyramid scheme.
Oh, no. Oh, 7-8 got it. 7-8 got it. Go to 7-8.
Which one?
The very first one. The very first entry.
Oh, we have a winner.
There we go.
I don't know who that is, but they won every fake period.
Yeah, so there's something called an internal transfer. This is a bit confusing. Basically, there's an explicit call which is generated by kind of an owner, like an owner-controlled address, and then there are transactions that are generated from smart contract functionality. And so the payout was generated by the smart contract, right? That 3 Ether, or the balance of the lottery was sent via kind of an internal execution.
No, but you have to close the lottery, and that's what triggered it, no?
That's right, that's what triggered it, but it's kind of like a second order effect. And so the way that Ethereum classifies that second order type of transaction is like an internal transfer, it's called. It's a
So
call.
why is it secondary? Because I saw right there you have a function that gets called in that function.
That's right, but there was no value associated with the close lottery call, right? We didn't send any value with that close lottery call.
Oh.
The value was sent from the smart contract to someone else.
Oh.
So there's a bit of a distinction.
You mean because the miners need to get paid? Is that what you're trying to get at? You know?
It's more just a technical.
Yeah, it's like
That's just the
it's
amount
basically
of
just the way that it's made programmatically. So I called closed contract, but
Let's look at that code again. Is your case it's gone forever?
I called closed contract, but
Let's look at that code again. Is your case it's gone forever?
No, I think no. Here you go. Plug in yours.
Is it on the Web3 contract tab?
Oh right, you did verify the code, didn't you?
Yeah, you can. Yeah.
Let's do it. But so basically, when I call closed contract, I'm not transferring any Ethereum.
Okay.
So there it checks, okay, is there a transfer? No, there isn't. But then the contract after it, while it's executing things, basically is triggered to transfer
Where is
funds.
that executed?
It's executed within the function.
On which server?
There are no servers.
Every miner executes every transaction that's broadcast to the Ethereum blockchain. Every miner executes it. Yeah. It's a bit weird.
For free in this instance?
No, so we paid them gas. We didn't send any
I paid about
value.
16 cents.
Oh, when you called that,
Yeah, so if
you
you
paid 16 cents.
I can show you.
American cents?
Yeah.
Well, in Ethereum, value wise.
Really?
So if you look here, you can see.
And it got executed by all miners around the globe. How many miners are there?
thousands,
Millions.
millions.
Millions?
Originally thousands 2 years ago. Millions.
So you can see the value that I sent was 0,
Dollars, I don't know.
Yeah.
but this is gas price,
Well, you paid for
which
the-
was
Really?
0.49
That's a
Ethereum.
lot.
Okay.
So in total, the fee was this, which is about 16 cents.
Why does it say 0 over there?
Because it's